Yes, mom.
Have you faced any problem or you have already done this one?
Like, for me, can you just explain it again?
Yeah, here the theorem says the diagonal of a parallelogram bisect each other. So if we are having a parallelogram, and let's say parallelogram ABCD, we have to show that the diagonal, this diagonal and this diagonal bisect each other. That means both the diagonal are cutting each other into equal parts. Have you done? So here, basically we can start with this one. We can take this triangle and this triangle. Any two triangle we can take over here. We can say that AB and CD are same. We want to prove these two are congruent, right? So we can
Yes,
say in triangle AOB and COD. AB and CD are same since it's a parallelogram, right? We can also say that this angle and this angle are same. Why? It's a parallelogram, alternate interior angle. What else we can say? We can also say that this blue angle and this blue angle are same. Again, why? It's a parallelogram. So are we getting anything? It's angle, side, angle. Okay, side is sandwiched between angle, both the angles. So angle side angle congruency rule will say this two triangle, triangle number 1 and triangle number 2, both are congruent. If triangle number 1 and triangle number 2 are congruent, then we can say their corresponding part will be equal, right?
yes. Mom, triangle DOC and BOC are equal, right?
DO,
C and BOA.
yeah, that also we can take.
Okay.
So basically from the congruency criteria, whatever criterias we are having, side angle side angle, angle side, RHS, we have to check which one we can, like which angle, which side we will be taking so that any of the criteria will be matching over here. Okay. So here you can say whatever I have shown, by that only you are getting angle side angle criteria. And there is one criteria where the angle, the side included in between both the angle and another angle, if these are getting same, like if you are getting this one as a same in both the triangle, then you can say both the triangles are congruent, right? Without even taking OO. This is only helping us, right?
Yes,
So we can say by angle side angle congruency criteria, both the triangles are congruent. Yes, whatever you said, that is correct. But without even taking the help of that one, we are able to prove that the triangle, both the triangle are congruent, and hence AO, CO, OB, OD by CPCT. Yes or no?
yes,
And hence we can say the diagonal is bisecting each other. Can you see it? AO is equals to CO, that means diagonal is getting bisected. BO is equals to DO, that means diagonal is getting bisected, right?
yes,
So basically, whenever it says that we are having a parallelogram, just list down what we are having in hand, the information. Now we have to show that diagonal are bisecting each other. So basically, we wanted to show AO is equals to OC, BO is equals to OD, and that we have done over here. Got it? You can take any two opposite triangle and you can go ahead with the same process. So triangle 1 and 2 I have shown over here. Instead of that, If you want to take triangle, this yellow one and the other yellow one, that both, like these two, will also help you to prove the same thing. So it's completely up to you which two triangle you want to take. Why we are taking opposite triangle only? Because parallelogram gives opposite side only same, right?
Yes, ma'am.
Why we are taking opposite triangle, and on the basis of that we are able to prove that the diagonals are bisecting each other. Got it?
Yes, ma'am.
Let's move ahead. Now I'm going to take few questions from the exercise. Okay. So the first question is, if the diagonal, here all are theorem only, and the main thing is all the theorem are related to the congruency concept only. So if you have understood the concept of congruency very well, this chapter will be very simple for you. So here the question says, if the diagonal of a parallelogram are equal, then show that it is a rectangle. We are having a parallelogram. Let's read it and understand it first, okay? Because this will be very confusing if you are not going to, like, if you are not understanding the statement properly. So here the statement says, if the diagonal of a parallelogram, okay, so we are having a parallelogram. Let's say parallelogram ABCD. ABCD is a parallelogram. Let me write it over here so that we will be clear with what is given. So it is given that ABCD is a parallelogram. Now again I am reading the first statement. It says that if the diagonal of the parallelogram are equal, diagonal of this parallelogram are equal. So if we will be drawing the diagonal like this and like this, both the diagonal are equal. It is already given in the theorem. So it is also given that AC and BD both are of same length. This is also given. What we have to show? We have to show that this is a rectangle. That's why on day one I was telling you that please memorize all the quality of each and every quadrilateral. So we have to show it's a rectangle. Now what is the property of the rectangle? Rectangle is also a parallelogram. So just like parallelogram, rectangle is also having opposite side same, opposite side parallel. So every property of parallelogram will be followed by rectangle. But apart from that, rectangle is also having its own qualities. Few qualities are there which is extra qualities which is there in the rectangle. What is that quality? So that quality is, apart from having all the quality of parallelogram, rectangle is having each and every interior angle 90 degree. Yes or no?
Yes, ma'am.
So if we will prove that this parallelogram is having each interior angle as a 90 degree, then it will be a rectangle, right?
Yes.
Getting it? Understood the theorem first? So we were having the information ABCD is a rectangle. ABCD is a, sorry, parallelogram where diagonals are same. Diagonal AC and BD are same. Show that it's a rectangle. How we will be showing it's a rectangle? There is a few qualities which only rectangle is having. That quality if we will prove over here, then we can say it's a rectangle. What is that quality? That each interior angle of the rectangle is 90 degree. This property, like parallelogram doesn't follow this property. Parallelogram is like this. Here each interior angle, this is not 90 degree. Okay, this is valid for rectangle or square, we can say. So let's move ahead and let's prove that each interior angle is 90 degree. Then we will be able to say it's a rectangle. Now ABCD is a parallelogram, means AB is parallel to CD and AB is equals to CD. What else? ABCD is a parallelogram, means AD is parallel to BC and also AD is equals to BC. All the quality of parallelogram I am writing. Why? So that we can use it to prove congruency again of any two triangle, which will help us to prove that each interior angle is 90 degree. Okay. So if we are taking each interior angle is of 90 degree, that's what we want to prove. So let's take any triangle. Let's take this triangle. Triangle ABD. And what else? So let's take the other triangle where the other side must be there of a parallelogram. Then only we will be able to prove the congruency. So let's take the other triangle as a this green triangle. So pink triangle and green triangle. Why pink and green? So that we can use the the information which we are having in hand, that is AB is equals to CD for parallelogram. So accordingly we are choosing any two triangle you can choose by yourself. It's not like there is no rule that you have to check, you have to take this two triangle only. Any two triangle where you will be able to use this condition, please take that. So I am going to take the pink triangle and the green triangle. That means triangle A, B, D and triangle other one A, D, C. Is it okay?
Yes, ma'am.
Now here I am going to say AB from here is equals to CD from there. How? Because ABCD is a parallelogram. What else we are having? Here, can you see side AD is there? In side AD is colored with pink also, side AD is colored with green also. Can you see?
Yes, it's common side.
Common side. And one more information was given in the question. AC. Okay. We have written ABD triangle at first. That means BD side. BD is equals to AC. Is it okay? Given already. Both the diagonal are of same length. Clear?
Yes, ma'am.
Now let's write the name of the triangle properly. Then only we will be able to prove that, then only we will be able to go ahead and we can use CPCT or something. So we need to write the sequence of the name properly. A, B, C, D. Okay. A, B, C, D, B, D, A, C. Okay. So let me write it reverse way. Let's check it whether we have written the name properly or not. So the name says AB side is equals to CD side. AB, CD or DC is the same thing. Now AD is equals to AD. So AD, AD. Why I am writing the name properly? So that again we can go ahead and we can use CPCT without even looking at the figure. Okay. BD is equals to AC. BD is equals to AC. Okay, your name of the triangle and my name which I have written can be here and there, but Your triangle name and your triangle name also must follow this sequence, that AB is equals to CD, AD, AD, BD, AC. This sequence must be followed in your name of the triangle also and my name. Okay, the name can be here and there. So this two triangle are congruent with each other. Now what we want to prove? We want to prove that each interior angle is of 90 degree. So for the pink triangle, what is the name of the pink triangle? ABD. Okay, for the pink triangle, angle BAD. Can you see angle BAD?
Yes.
That's what we wanted to prove as a 90 degree. So here angle BAD is equals to angle ADC. Is it okay from here by CPCT? Is it okay? Angle A from here is equals to angle D from here. Is it okay? Is it
Yes.
clear? That's why we have written the name properly. We have written the case that these two will be equal by CPCT. That means angle BAD and angle ADC both will be equal. I am saying we are having a parallelogram ABCD. A, B, C, D. Here we have drawn the diagonals as well. And we are saying that angle BAD, that means we are saying that angle BAD, this total angle is equals to angle ADC, this total angle. Okay, by CPCT we are writing it. Now what we can say, since it's a parallelogram, since ABCD is a parallelogram, can I say the adjacent angle sum will be 180 degree? These two will be supplementary with each other. Co-interior angle on the same side, like interior angle on the same side. Since AB and CD are parallel,
Yes.
there is a line like this. So these two are interior angle on the same side. We have already discussed this one when we were discussing about the qualities of parallelogram, right?
Yes.
So we can write angle BAD plus angle C or ADC. This sum will be 180. Co-interior angle or the property of parallelogram or interior angle on the same side. Okay. Now these two are already same. We have written this one that these two are already same, and the same two we are adding and writing is equals to 180. So let's write it. Let's substitute any one of them. So angle BAD plus ADC also I am writing angle BAD because both are same only, is equals to 180. 2 times angle BAD is equals to 180. Therefore angle BAD we got 90 degree. That's what we wanted to prove, that each interior angle is of 90 degree, hence it's a rectangle, right?
Yes.
So we ended up proving, hence parallelogram ABCD is a rectangle. Let's see from the very beginning what we have done exactly. Let's see. If the diagonal of a parallelogram are equal so that it's a rectangle. We already know rectangle is a parallelogram only. But rectangle is also having its own particular qualities. So if there is a parallelogram, it can be rectangle, it can be rhombus, it can be square. But the condition is, whenever we are saying it's a rectangle, it must be having its own quality also. Whenever we are saying it's a rhombus, it must follow the quality of the rhombus also, which is extra from the parallelogram. Whenever we are saying it's a square, then it must follow the quality of square also, apart from following the quality of parallelogram. Okay, so if it's a rectangle, then that means we have to show that the property of rectangle, any of the property of rectangle. So one of the property of rectangle says that each interior angle of the rectangle is 90 degree. So let's prove that. How we can go ahead and prove that? So we are taking two triangles over here. Any two triangle you can take. Since we are having in hand the information that it's a parallelogram, that means AB is equals to CD, AB is parallel to CD, AD is parallel to BC, AD is equals to BC. Both the diagonal are also same. So accordingly, we have taken two triangle. Okay. And we have proved that both the triangles are congruent. Once we have proved that both the triangles are congruent, now our focus is completely on taking two interior angle of this parallelogram. So we are taking two interior angle from the first triangle. After proving the congruency, we realize that one of the angle from the pink triangle is equals to another angle from the green triangle. That we have written as a equal. Now these two are equal, we are keeping it aside. Now the parallelogram condition says that sum of adjacent angle is supplementary in a parallelogram due to parallel lines. So that condition also we are taking since it's a parallelogram. And then we have proved that it's a rectangle. Is it clear to everybody?
Yes, ma'am.
This is how we will be proving it. You need to practice it at least like 2 to 3 times with a gap, with a proper gap. Then first time you are going to do it, and maybe if you need help, you can see this. You need to note it down and you can go through it first time when you are doing. After that, when you are doing it, you are going to try it completely by yourself. Okay. And third time, definitely you must do everything just by understanding the concept, not by memorizing the theorem. Okay, let's move ahead. Now another question says, or the theorem says, show that if the diagonal of a quadrilateral bisect each other at right angles, then it's a rhombus. So what we know here, what we have to prove here, first we will be focusing completely on the theorem given. So show that if the diagonal of a quadrilateral means any polygon having four sides. ABCD is just a quadrilateral. What we know? We know that ABCD is a quadrilateral, a polygon having four sides. Now, if the diagonal of this quadrilateral bisect each other, so diagonals are bisecting each other. That means it is given that in this quadrilateral AO, OC both are same, BO, OD both are same. It is given over here at right angle. So diagonals are bisecting each other at right angle. Here we are having 90 degree. Here we are having 90 degree. Here we are having 90 degree. And here also we are having 90 degree. That too is given over here. So let's write it. It is given that angle AOD is equals to angle COD is equals to angle COB or BOC, whatever you want to write it. All are 90-degree because diagonal are bisecting each other at right angle. These are the given information. In triangle chapter, what you used to do? In triangle chapter, all the information used to be given and something used to be given that we have to prove this. So here all the information is not given. Okay, sometime it's saying it's a parallelogram, sometime it's saying bisecting right angle. We have to list down first what are the given information we are having in hand, and then it's a rhombus. So we have to prove that this quadrilateral is a rhombus. We will be thinking, what is the extra quality of rhombus? What is the particular quality of
All
rhombus?
sides are equal.
All sides are equal. So if we will be able to prove that AB is equals to AD is equals to CD is equals to BC. If we will be able to prove that, then we can say it's a rhombus, right? Right?
Yes, ma'am.
So how can we prove so? Again, congruency. Which two triangle we want to take? If you will take this triangle, and if you will prove that AB and CD are same, still we cannot say it's a rhombus because that will be a parallelogram, right?
Yes, ma'am.
If you will be able to prove these two green triangle are congruent, that means ABCD are same. And if you will prove that this pink triangle and this pink triangle are congruent, that means ADBC are same. Still, you will be able to say it's a parallelogram, not a rhombus. For rhombus, we need to say all the sides are same, right? So rather than going by this method, what we are going to do, we can take any two adjacent triangle. We are directly going to prove that this triangle and this triangle are congruent. We will check whether it is possible to prove these two are congruent or not. If we will be able to prove these two are congruent, if that is possible, then we can say from here side AD and CD are same. Similarly, we can write similarly CD and BC are same. Similarly, BC and AB are same. Therefore, all are same. AB, BC, CD, DA, all are same. Okay, so if we will prove any two adjacent sides are same, then we can say similarly all the adjacent side will be same. Hence, AB, BC, CD, DA all will be same. It's a rhombus. Okay, getting it?
Yes, ma'am.
So rather than proving it's a parallelogram, directly we can prove, I believe directly we can prove that adjacent triangles are congruent, and hence adjacent sides are same, and hence all the adjacent side will be same, and hence it's a rhombus. Let's see whether that is possible or not, whatever we are thinking. So let's take that. If we will be taking triangle AOD and triangle DOC, let's see whether it is possible or not to prove. So we know AO from here is equals to OC from there, right? I'm
Yes, ma'am.
talking I'm talking about this green triangle and this blue triangle. Okay, so we know that AO OC are same. What else we know? We can see one common side is there. Can you see?
OD. Yes.
And one right angle is there and one right angle is here. Can you see? Angle AOD is equals to angle DOC. Both are 90-degree. It is given, right?
Yes, ma'am.
Now let's see whether any congruency criteria is getting fulfilled or not. So let's see. Angle,
Yes.
okay. SAS, obviously, yeah. Side, side. So SAS criteria is saying that these two triangles are congruent. Now what will be the name of the triangle? That too we also need to write properly. So the name of the triangle according to the information which we have listed down, AO.
OD is the common side, right?
OD is the common side. Yeah. Can you see?
Yes, ma'am.
So name of the triangle will be AOOC. We need to write both the thing at the same place. So we will be writing AO and CO. OD, OD. Okay, OD here, OD here. AOD, DOC. Okay, yeah. Both the angle O are same. That is 90 degree that we have written. Okay, it's not angle, it's triangle. This triangle and this triangle are congruent with each other by, of course, side angle side, which you have already identified. Now, what we wanted to show, we wanted to show that adjacent side are same. AD and DC are same. Is it same according to our sequence? AD and CD are same. Yes, it's same. AD and CD are same by CPCT. And ADCD, look at the figure ADCD. Both are adjacent side, right?
Ma'am, how are they equal to CPCT?
By CPCT, these two are equal because both are sitting at the same place, AD.
Oh, okay. Oh, okay, got it.
Okay. So ADCD are same by CPCT. By congruency, we can say that. And these two are adjacent side of our quadrilateral. Similarly, we can write. Similarly, CDBC will also be same. CDBC. Let me show you the figure. Similarly, CDBC will also be same. BCAB will also be same. ABAD will also be same. Any two adjacent triangle you will take and you will be able to prove both are congruent. Okay, so we don't have to prove so many times. Similarly, we can write that. Okay, are you getting it?
Yes, ma'am.
So I am going to
Yes,
write
ma'am.
CDBC. Yeah, please ask. Anyone?
But ma'am,
What? Anyone want to ask anything from here?
no, ma'am.
Okay. So BC, AB are same and AB, AD are same. Therefore, AB, BC, CD, DA all are same and hence ABCD is a rhombus. Got it?
Yes, ma'am.
Now let's do one tricky question. Okay. Here the question says, A, B, C, D. Here it says ABCD. I'm writing the question. Is a trapezium in which AB is parallel to CD and AD is equals to BC. This is the isosceles trapezium, right? Legs are same.
Yes.
Okay. Here we have to show that angle A is equals to angle B. We also have to show that angle C is equals to angle D. We also have to show triangle ABC is congruent with triangle BAD. And we also have to show diagonal AC is equals to diagonal BD. Now let's see how can we do so. First thing, okay, second, third, fourth, let's keep it aside for a while. So what we are going to do here, we are going to do at first one construction. To prove that angle A is equals to angle B, we need to do one construction over here. What is the construction? The construction, like we are free to do construction. Whenever one figure is given, and if we want to do any construction to prove whatever is asked in the theorem, then we are free to go ahead and we can do the construction. So here we are doing the construction. We are extending this side AB, and let's say this is D. We are extending it till D and we are joining this with C. Okay, this is the construction we are doing, and we are saying that here CD is parallel to AD. This is what we are saying over here. This is what we have done the construction. Now let's see how this construction is going to support, and how is going to support us, and how we are going to prove that angle A and angle B are same. That means we have to show that in previous trapezium, angle A and angle B, these two are same. That's what we want to prove over here according to the first part. Okay. We have done one construction by ourselves. So here, since it's a trapezium, bases are parallel, right? This is the base and these two are parallel already given. Can you see it?
Yes, ma'am.
Let's write it. AB is parallel to CD. Now there is a condition of a parallel line, that whenever you will stretch the parallel line, if you are having this, if this is a parallel line, this is a line which is parallel to maybe another line. So if you are going to stretch this parallel line, if you are going to extend it, it still will be parallel to the other line. Okay, I am saying these two are parallel. So if you are extend the above line, if you are going to extend it, still it will be parallel to this line. Or if you are going to cut the above line, if tiny part of the line, let's say this much part is left, still it will be parallel to this line. Getting it?
Yes, ma'am.
No, ma'am.
I am saying if you are having, let me show you.
So, ma'am, it's like that will be opposite of that line.
Yeah, what you said, Yatika?
Ma'am, it's like
Opposite?
opposite the lines. If you extend it or cut it,
Yeah,
the lights are parallel.
yeah. Lines are parallel, then even if we are extending it, it will be parallel. Even if we are reducing it, it will be parallel. Let me show you what I am trying to say. I am saying that AB over here is parallel to CD. Okay. Here we are having, let's say, point O. Here we are having point M. Okay. Here we are having T. Here we are having S. But actually, AB is parallel to CD. Okay. Now, if you will extend this line AB, if you are extending it, okay, if you are just extending this line AB and you are saying this is point P, then AP will also be parallel to CD. That's what I'm saying. Even if you are stretching the line, still it will be parallel to the other line. Okay? Or if you are reducing the line, let's say this is not P, you are going to reduce the line. Only AM is left. So AM will also be parallel to CD. So if two parallel lines are there, then even if you are stretching it or reducing it, still both the line will be parallel with each other. Are you getting it? Or
Yes,
if I am going to rub it more, now AO is only remaining. Still this AO will be parallel to CD. Now from CD also, if we are going to remove a part, so AO will be parallel to CS. Getting it?
yes, ma'am.
So if two lines are parallel, you can extend it, reduce it, whatever you want to do it, still both will be parallel with each other. Okay, so here we are saying in our theorem that since AB and CD are parallel, right, which is given in the question, this is given. Can you see AB and CD are parallel? Now, if we are
Yes,
going to
ma'am.
extend AB, still it will be parallel to CD. So if you have extended your line AB, that means now the line AB became AD. So this AD will be parallel to, okay, D already was there. Let me take another point over here. Let's say this is E, okay? CE, yeah. So if we have extended it, if we have extended the line AB, still it will be parallel. That means AE will be parallel to CD. Any confusion over here? If two lines
No.
were already
Ma'am.
parallel, you will stretch it, still it will be parallel to the other line. Okay? Now, can we say that AE is parallel to CD and CE is parallel to AD? Let me mark it. Hence, it's a parallelogram. Look at the figure and look at the highlighted part. Can we say according to the highlighted part, it's a AECD or ADCE is a parallelogram. This complete is a parallelogram. Can we say?
Yes, ma'am.
Yes.
Yes, we can say that because both the opposite sides are parallel with each other. So it's a parallelogram. Let's write it. Therefore, ADCE is a parallelogram. And since it's a parallelogram, opposite sides were already parallel, it will also be equal in length, right? Right?
Yes, ma'am.
Let's write it. AE is equals to CD. And what else? AD is equals to CE.
See,
E. Okay. Any confusion till here? Is it clear so far?
yes, ma'am.
Yes. No.
Okay. Now AD is equals to CE. And can you see this condition given? AD is
Yes,
equals to BC also. Let's write it. This was already given. This yellow part is this yellow part. I have just copy pasted AD BC. Now can I say from this two that CE BC are same? Can I say from 1 and 2? Can I?
Yes.
CE BC are same. Let's see what are CE, what are BC. CE side and BC are same. Since these two are same, does it looks like an isosceles triangle where two sides are same? This
Yes, ma'am.
triangle. If it's an isosceles triangle, can I say this angle and this angle will be same? Can I?
Yes.
So angle B will be equals to angle E, or the proper name will be angle CBE is equals to angle CEB. Let's say it's X. Let's say. Okay. So these two are X. Then can I say angle CBA will be 180 minus X? Linear pair. Can
Yes, ma'am.
I angle CBA, therefore angle CBA will be 180 minus X, linear pair. Next, if ADCE is a parallelogram, then can we say sum of this angle and this angle has to be supplementary? Adjacent angles are supplementary with each other, or you
Yes.
can say
Yes.
angle on the same side. So angle A and angle E are supplementary. Okay, since ADCE is a parallelogram. So if angle A is X, A will be 180 minus X. Yes or no?
Yes, ma'am.
Let's write it. Since
Ma'am, can you
ADCE,
scroll up a bit?
yeah,
No, no, not that up. A bit more down. Okay, yeah, perfect.
yeah. So we are saying since ADCE is a parallelogram, angle A plus angle E is equals to 180. Therefore, angle A will be 180 minus angle E, that is 180 minus X. And hence, what we needed to prove for the first part, that angle A and angle B are same. Can you see we have already proved that these two are same?
Yes, ma'am.
So let's name it as an equation. This was equation number 3, we can say. This is equation number 4, we can say. Then we can say from 3 and 4, angle A is equals to angle B. That's what we wanted to prove, right? Is it clear to everyone? Let's summarize this, what we did exactly over here. So, can I scroll up? Have you noted it down?
Yes, ma'am.
Okay, let's go
Yes,
ahead
ma'am.
and let's see what exactly we have done. There was a trapezium. It was an isosceles trapezium where few conditions were given, that bases are parallel and the legs are equal. That was given. And the first part is asking angle A is equals to angle B. So what we have done, we have extended the side. Let me draw the figure and let me show you. So we were having the trapezium like this, where bases are parallel, A, B, C, D. Here C was there. C, D. So here it was given that AB is parallel to CD, and it was also given that AD is equals to BC. We wanted to prove that angle A is equals to angle B. This is what we wanted to prove over here. We realized that without doing any construction, we will not be able to go ahead easily. So we have done one construction by ourselves. What we have done, we have extended this side and we have joined it with this. And now we are saying that this one and this one are parallel with each other. So in by like here we have done the construction in such a way that AD and CE are parallel. That's what we are saying. Now we realize that okay, this total ADCE is a parallelogram because already AB was parallel to CD. So this total line will also be parallel to this one. So hence it's a parallelogram. That's what we realize. Since it's a parallelogram, opposite side are parallel, that we have already seen the condition. Opposite side will be equal to each other. So we have written A will be equals to CD and AD will be equals to CE. Opposite side of this parallelogram are equal with each other. And it was already given in the question that AD and BC are same. Okay, it was already given in the question that ADBC are same, and we are saying it's a parallelogram and ADCE are same. So eventually we ended up getting BCCE are same. Since BCCE are same, hence it's an isosceles triangle where this angle and this angle will be just became same. And since this two angle became same, easily we have proved that angle A is equals to angle B. Getting it?
Yes, ma'am.
Mom.
Any confusion to anyone? The remaining part, the second, third, fourth part, I'll be giving the hint so that like you will be able to proceed. But that I'll be giving in the next class. You just finish till here. If you have given the assessment from the first topic of the quadrilateral, well and good. If you have not given the assessment, please go ahead and give the assessment. Okay.
Okay, ma'am.